Assalamu alaikum. A'udhu billahi minash shaitani rajim. Bismillahir rahmanir rahim. We seek refuge in the name of Allah from Shaitan, the rejected one. In the name of Allah, the most gracious, the most merciful. J'espère que tout va bien. Last time we did this one, we were looking at the pH d'un amphoté. We said that un amphoté, c'est un anion possède à la fois un caractère acide et basique. This is an ion which behaves like a base and sometimes it behaves like an acid. And we came up with the formula for finding the pH of an ion. We said that the pH of an ion is given by 1/2 pKa 1 plus pKa D. This is where we ended. This is what we did last time. We ended here, if not mistaken. Expression classique du pH d'un ampholyte ne dépend pas de... I'm unable to get you. Is it possible that you can repeat yourself? The one who was speaking, I didn't get anything. The network was tripping. Is it possible if you can repeat what you said? Was it Jabez or Kenneth? I didn't get if it was a question or what. Would you repeat yourself?
I don't know. I think the one who just forgot to turn off the mic.
Okay. No problem. It happens. So we continue. So this is where we did this, not so. You remember last time we were using this, where I had started explaining something and then you didn't correct me and say, Simon, you were on a wrong page. Then I said, okay. I had gone to the correct page. This one, you remember this? We did last time. Yeah, we did this. We came up with the pH of an ampholyte here. So I had said explaining this, which is what we are going to look at later on in some minutes from now. So when you have an amphoté, this is the pH of finding that solution. So we are going to move. Today we are going to look at a mixture of acids and bases. How can we find the pH of a mixture of an acid and a base? Because the pH of an acid, it is not the same as that of a base. So we are going to see how can we find the pH of unmélangé base, unmélangé des acides et des bases. So the first one, acid 1 4, acid D. Yeah, acid D4. So in this case, we are going to look at a mixture of acids, like a mixture of acids. Acid 1, a strong acid. Acid 2, a strong acid again. The base acid is from 4. Acid 1, A, acid D. So H3O plus is equals to, so the concentration of hydronium now, it will come from both acids. Well, so the final concentration of hydronium, it is the one we're going to use to find the pH. So the final concentration of the hydronium is equal to the concentration of the hydronium which comes from acid 1 plus the concentration of the hydronium which comes from acid 2. Now, from acid 1, we know, like from more concept, that if we say concentration 1 times volume 1, meaning we are finding the number of moles for acid 1. So if we want to find the number of moles for acid 1, we say concentration 1 times the volume 1. If we want to find the number of moles for acid 2, we are going to say concentration 2 times the volume 2. So Here we're adding the number of moles of the H2SO plus, which comes from acid 1, plus the number of moles of H2SO plus, which comes from acid 2. So if we have the total number of moles of this acid. If we divide by volume, meaning that we are going to come up with the final concentration of H2SO plus. So get it, like we have two acids, we've put two strong acids together. One acid is going to give out a certain number of moles of H2SO plus. Another acid is going to give out a certain number of H2SO plus. So for us to find the total number of what? For us to find the total number of H2SO plus, find the total number of moles of H2SO plus, meaning we are going to add the number of moles of H2SO plus, which comes from the first acid, plus the number of H2SO plus from the second acid. And then now we need to take into consideration the concentration. So like if the first acid, its volume was 50 moles, and the second acid, its volume was 50 moles. When we put them together, what is going to be the total number of volume? It will be 50 moles plus 50 moles, which is 100 moles. So if we want to find the concentration, we say the total number of moles of H2SO plus, meaning moles from acid 1 plus moles from acid 2, divided by that total number of what? Of volume. So this is the concentration of H2SO plus. So pH, since this one is a strong acid, so pH is equals to negative log of the concentration of H2SO plus, which is equals to negative log of what is the concentration of H2SO plus. The concentration of H2SO plus is given by the number of moles from acid 1 plus the number of moles from acid 2, everything divided by the volume total. Is it clear here?
Yes.
Okay, we proceed. Then la deuxième condition. Acid 1 for acid D faible. So here we have an acid which is strong and another acid which is weak. Pour des concentrations voisines, c'est l'acide le plus fort des deux acides qui impose son pH. Si concentration 1 squared is greater than or equals to 10 times concentration D times Kd. So we have a mix of an acid which is strong and another acid which is weak. So if we want to find the concentration first, we need to look at this condition. If we say, okay, if the acid one, it is the one which is strong, meaning if we square the concentration of the acid one, if we find that this the value that we get after squaring the concentration of acid one, it is greater than or equals to 10 times concentration of acid D times the constant of acidity of the acid D. If this condition is satisfied, meaning that the pH is going to be found using the concentration of acid 1, it means that we are going to apply the same formula, but we are just going to take into consideration acid 1 because this condition is verified. So we have another one, acid 1 faible plus acid D faible. So here we have a mixture of two acids which are both weak acids. Là encore, pour des concentrations voisines, c'est l'acide le plus fort des deux acides faibles qui imposent son pH si Ka1, si concentration 1 superior or equal to 10 times KdCd. So if we have like if we have such a mixture of two acids which are both weak acids, and then the concentrations they are almost the same, like almost, but not very close, like just neighboring. So if we want to find the pH now, the pH of this one is going to be found, as in it will be influenced, or maybe let me put it this way: we have two acids. They are both weak acids, but the weakness of the first acid, it is not equal to the weakness of the second acid. Both acids are weak, but one is going to be weaker than the other. So if we say Acid 1, it is the one which is a little bit stronger than the other, meaning we need to use this condition. So the constant of acidity of acid 1 times its concentration. If it is greater than or equals to 10 times the constant of acidity of acid 2 times the concentration of acid 2. If this condition is verified, it means that the pH is going to be found using what? Using the concentration of acid 1. So let's go. Let's see an example so that you can understand it better. We've got pKa1, which is NH4+. Its concentration is 0.1. So the concentration of NH4+, this is an acid, it is what is 0.1. So pKa1, it is what? 9.2. CH3COOH, this is another acid, its concentration here, and pKa is equals 4.8. So here, if we check here, like CH3COOH imposed repair, this is the acid which is going to what? Which is if we use this condition saying Ka1, so using pK. So like if you have a pen there, you can do this. pKa, it is given by 10. I mean Ka, it is given by 10 to the power negative pKa. So here 10 to the power negative 9.2, 10 to the power negative 9.2 times the concentration is 0.1. It must be greater than or equals to this 10. I mean, no, this is the acid which is going to impose the pH, sorry. So it's 10 to the power negative 4.8. 10 to the power negative 4.8. Since here they've said that CH3COOH imposes replace, meaning this is the one which is considered as which is supposed to be on this side, the replacing Ka1C1. So 10 to the power 4.8 times the concentration 0.1 must be greater than or equals to 10 to the power negative 9.2 times its concentration in this one. So this condition is verified, meaning this CH3COOH is the acid which is going to impose the pH. So this one, it is a weak acid. This one, it is a weak acid. And pH of a weak acid is given by pH is equals to 1/2 pKa minus log of concentration. pKa minus log of concentration. So here where there is Ka, we're going to replace with what? We're going to replace with the 4.8 pKa. It will be replaced by 4.8 minus log of concentration. What is the concentration is 0.1 is equals to 2.9. Let's just verify if what you are saying is correct. Maybe we might have swapped. So 0.5 times in bracket pKa 4.8 minus log of concentration 0.1. So this is 2.9. It is correct. So we have another condition here. We have another condition, but just before we go to this condition, I've got something that I want to verify. Okay. Donc, si Ka is less than 10 times KDCD, il faut donc tenir compte des deux acidités simultanément. Example. So, if we have something like this, where the concentration, as in the constant of acidity of acid 1 times the concentration 1, if it is less than 10 times the constant of acidity of acid 2 times the concentration 2. If we have this condition, if this condition is verified, meaning that both acids are going to take part in what? Both acids are going to take part in influencing the what? In influencing the pH, meaning that we need to take into consideration the concentration of both acids. So example, we have this one, HCOOH. This is what we've been given as the concentration 10 to the power negative 1. 10 to the power negative 1 has been given as the concentration. And then pK1 of the acid 1, it is 10 to the power negative 1. And for this other acid, CH3COOH, one mole per liter. This M grand M, it represents mole per liter. So pK per day is given by 4.8. So here you must pay extra attention. Here we've got this acid and this acid. Both of them are what? Both of them are weak. But this acid one, if we multiply its constant times its concentration, it is less than 10 times the constant of acid 2 times its concentration. So here we've got acid 1, we've got acid 2. A liter initial, honor the concentration of acid 1 and the concentration of what? Of acid 2. Here, when this and this decompose, they are going to form this one, base conjugate, and acid H2SO plus. So, at equilibrium. So when this one reaches equilibrium, so we want to find the number of moles of H2SO plus that we have formed. So we are going to take at equilibrium. This one, we will take the decomposition of this one, meaning this one we will ignore it first. So at first, when this one decomposes, it will form its base conjugate HCOO0, and the number of moles formed of the number of these will be the number of moles formed for this acid of 1C1, and these will be the number of moles for this other for H2SO plus formed. And then this one now, this one, it is what? It is ignored now. We will consider this one, the CH3COOH, and this one, like it decomposes, it will form its base conjugate times it will also give out what? H2SO plus, which are these are the number of H2SO plus, meaning that now the number of moles that remained, like these are the number of moles for that decompose for this acid. These are the number of moles that decompose for this acid. So the number of moles that remained now for this acid, it will be given by C day 1 minus alpha day, C1 1 minus alpha 1, and then this is the same. The number of moles formed for this, the number of moles formed for this. Our main aim is to find the total number of moles for H2SO plus. So it will be the number of moles of H2SO plus from acid 1 plus the number of moles of H2SO plus from acid D. That's what we have, R1 C1 plus AD C D. So the way we fill this table, it is the same. Just consider that at first you don't have this acid. Then you write the decomposition of this acid. You will get it here, this one, and this one. And then you will consider that you don't have this acid, write the number of moles of this acid. You have this one, and this one. That's how it is. So don't get scared how to fill this table. You have been doing it. So Ka1, the constant of acidity of the decomposition of acid 1, it will be given by the number of moles of H2SO plus from acid 1 times the number of moles of the base conjugate divided by the number of moles that remained for this acid. Same, constant of acidity for acid D is given by the number of moles of H2SO plus times the number of moles of this one, say base conjugate, divided by the number of moles that remain. So you are seeing here there is what? There is H. There is H, you will see. So you will see what H is on the next page. So alpha 1 from the acid one, it is less than 0.1, and alpha D of acid D is less than 0.1. So ash, it is what? Ash, it is the constant. Ash is the concentration of what? Ash, it is the concentration of H2SO plus, meaning that ash, it is the what? The concentration of H2SO plus, which is given by acid 1 times concentration 1 plus acid D. I mean alpha 1, not acid 1. Alpha 1 times the concentration of acid 1 plus alpha D times the concentration of acid D. So if you write constant of acidity 1 times the concentration of acid 1 plus the constant of acidity times times the concentration of acid D, you are going to get this one. Alpha 1 times concentration of acid 1 times, this is the H. What is H? H, it is this one, plus alpha D, concentration of acid D, times H. H, it is this one. So K1 C1 plus KD CD, it is the same as writing H squared, like squaring this one. So just a minute, let me check if I simplified this one. So this is what we are looking at. We said that K1 times concentration 1 plus KD times concentration of D. As in K here, I mean the constant of acidity. This one times concentration plus this one times the concentration. It will give what? Alpha 1 concentration 1 times H plus alpha D concentration D times H, which is the same as H squared. So that's what we have here. So now, like here, we have this one, alpha 1, like from what we have here, pay extra attention here, like from what we have here, I've just factorized what? Just factorized this H, like H is outside, open bracket. We're going to remain with what? Alpha 1 concentration 1 plus alpha D concentration D. And alpha 1 concentration 1 plus alpha D concentration D itself, it is what? It is H from what we've been told. It is what? It is H. This is the this from acid 1, this from acid D. So this is H times H, which is what? Which is H squared. So meaning that H squared, it is the same as K1 concentration 1 plus KD concentration D. And what is H itself? H, it is the concentration of what? The concentration of Leon hydronium H2SO plus. So if we write H squared, it is the same as writing the concentration of H2SO plus squared. So here we have concentration of H2SO plus squared is equals to constant of acidity 1 times concentration of acid 1 plus constant of acidity acid D times concentration of acid D. So if we introduce negative log on both sides, we're going to have negative log of H2SO plus squared is equals to negative log of this. And then these two will drop, it will come in front, and then we pass negative log inside the brackets. It will be 2 times negative log of H2SO plus is equals to negative log of this. And then I didn't like distribute the logarithm. Then what is negative log? Negative log of concentration of H2SO plus. It is what? It is also called pH. So pH is equal to negative here I will divide by 2 both sides. So I have pH is equal to -1/2 times log of K1 C1 plus Kd Cd, meaning that if we have 2 acids, this is the pH that we're going to use if both acids are weak, and the constant of acidity 1 times the concentration of acid 1. If it is less than 10 times constant of acidity of acid D times concentration of acid D. If that condition is verified, meaning you have to go direct find the pH using this formula. So when you've been given a question, you will see, like, I've prepared some questions. I've sent a PDF in the group. So there are a lot of questions there. You will see, like, what do we have to look at first when we've been given a question. So these formulas, you must know them by heart. Know the formula, know the condition. Know the formula, know the condition again. So this is what we have here. So pH is given. So for, as in from this one, if you substitute here, where there is K1, you replace with the constant of acidity of acid 1. You replace here, where there is you replace. For this question, you are going for this question. Since you've been given the values for this, you just have to replace for pKa1, pKa of acid 1. It is given by this, meaning if you want to find Ka, I showed you already how to solve this one. Ka, as in how to convert the pKa to Ka. So since pKa is given by negative log of Ka, meaning that Ka will be given by 10 times negative pKa. If you've forgotten, let me just show you. If it is here, I hope it is here. Yeah. This one, if you want to find Ka, you just have to go direct. Ka is equals to 10 times negative pKa. That's what we have here. Ka is equals to 10 times negative pKa. In most of the questions, they won't be giving the value for Ka. They're giving the value for pKa. So you have to know this one again, the conversion. It's just a simple mathematics. So if you replace the value, if where is it? Yeah, so if you replace it, if you replace the value for the, if you replace the values correct here, you've been given everything in the question. You are going to find that the pH is equal to 2.25. So remark, l'ion des acides est négligeable devant l'autre. See, so meaning one acid is going to be ignored, like before the other, or in the presence of the other acid, if this condition is verified. I've explained this one already. Dans le cas d'un mélange acide fort et acide faible, KDCD, il suffit de comparer rapidement C1 squared et KDCD. So we have talked about this one already. So l'acide fort impose le pH. This is just the summary. So here we have mélange d'un acide faible et sa base conjuguée. Mélange d'un acide faible et sa base conjuguée. Solution Tompo. So we're going to look at the solution Tompo. So what is solution Tompo? Solution Tompo, it is a solution which is formed by mixing an acid faible and its base conjugate. So you can't have a base conjugate like existing in its own. So you are going to see how we can come up with this solution. So la solution Tompo, définition, la solution Tompo est caractérisée par un pH qui varie très peu par l'addition d'un acide d'une base ou par dilution. So here, from using the definition, they're saying that a solution Tompo, it is characterized by a pH which does not really change when you add an acid, or when you add a base, or when you add water dilution. So the pH, the change is not significant. The change is very small, such that it is neglected and it can be considered as there is no change when you add an acid or when you dilute it. So we are going to see even if we dilute it, the concentration reduces. But why doesn't this solution change? Why doesn't this pH? Why doesn't this pH? Why doesn't this solution change its pH? Normally, when we add water, we influence the pH because the concentration has changed. But in the case of a solution tompo, even if you add water, the concentration will not change. Sorry, let me repeat my statement. I've said that like when you're dealing with acids and bases, when you add some water, the concentration it changes, meaning that the pH is going to change. But in the case of a solution tompo, even if you add water, regardless of the quantity of water that you're going to add, the concentration is going to change, but the pH is not going to change. So you are going to see why the change in concentration does not influence the change in pH. So, la solution tompo, elle est obtenue par le mélange. So we can come up with a solution tompo by mixing acide faible et sa base conjuguée, ou d'une base et son acide conjugué. Par exemple, on a mélange de CH3COOH. This is an acid plus this is a salt. So this salt, when you remove sodium here, sodium Na plus, you're going to have CH3COO minus. This is the base conjugate of this acid. Or melange of NH3 and this salt, NH4 ammonium chloride, this one. When you mix this one and this one in order to form a solution tompo, when you mix this one and this one in order to form a solution tompo. So we are going to look at how to find the pH of a solution tompo. pH d'une solution tompo. Mélange de this one, which we've already seen in the example. So let's say this salt, then l'eau, c'est dissout complètement. So this salt, when you put it in water, it will decompose, forming this one, base conjugate of this acid and forming sodium ion. Entre l'acide et sa base conjuguée, il y a un équilibre. So when this acid decomposes, it will form what? It will form this base conjugate, like it will form the base conjugate plus H2O plus. So there is an equilibrium reaction between these two because this is a weak acid. So just a minute, let me see if I prepared something for this one. No, it's not here. Okay, so we'll continue. So here, this is the decomposition of this acid. This is the decomposition of this acid. So when this acid decomposes, it will form what? It will form H2O COO minus plus H2O plus. Remember that we said that here we've got a mixture of this acid and water. So this acid, not water, salt. We've got a mixture of this acid and this salt. This is an acidic salt. So when you put the salt in water, it will decompose totally, forming this one and this one. So this acid now, if it's put in water, it will form an equilibrium reaction, whereby it will decompose, forming the base conjugate CH3COO minus plus H2O plus. So these two equations, they make up what? They make up, as in these two equations, they are all, like they come from the mixture of this and this. So Card if you want to find the constant of acidity for this one, you say the concentration of H2O plus times the concentration of this one divided by the concentration of the acid. That's what we have here. That's what we have here. So pH. So pH now, it is going like using this one. What we are going to do here, we are going to cross multiply. We are going to cross multiply this one, KDA times the acid, meaning to be concentration of the acid times KDA is equals to concentration of base conjugate times the concentration of H2SO plus. So here we want to make H2SO plus subject to the formula, meaning when you want to make H2SO plus subject to the formula, you are going to divide both sides by concentration of CH3COO negative or minus. So when you divide both sides, meaning you are going to have concentration of H2SO plus is equals to KDA times concentration of CH3COOH, everything divided by concentration of this base conjugate. So when you introduce negative log on both sides, you are going to find that pH, meaning that negative log of this one is pH, it will be given by pKa plus log of the base conjugate over the acid. If you remember, we came up with this formula when we were just doing acids and bases. Yeah, when we just introduced this topic, you should try to, if you've forgotten how we arrived here, try to revisit that topic. Like here, there was buzz. Here there was B. Here there was A. If I remember, meaning that A here was representing for an acid. B was representing for buzz, which is the same as this one. A minus is buzz conjugate. AH it is what? It is an acid. So pH in solution tompo. So the pH of the solution tompo, it is given by pKa plus log of the base conjugate over the concentration of an acid. pH of a solution tompo is given by the potential of the constant of acidity plus log of concentration of the base conjugate divided by the concentration of the acid. So how can we find the concentration of the acid? So the concentration of the acid, how can you find the concentration of the base conjugate? So the concentration of the base conjugate ammonia, it is given by number of mole of the base divided by the total volume. And the concentration of the acid, it is also given by, like we've mixed an acid and what? We've mixed like an acid and that salt. So from the acid, that's where we come up with what number of moles of the acid. From the salt, that's why we come up with the number, like number of moles of what? Number of moles of base. The volume, it is the total volume as in of the mixed. So the volume here, it is the same as the volume here. So this is the concentration of what? The concentration of the base conjugate. Number of mole of the base conjugate divided by the volume. Number of mole of the acid divided by the volume. Meaning, if you come here, you write NB, number of mole of base divided by volume. Again here, write number of mole of acid divided by volume. Meaning, volume and volume, it will cancel. Meaning, when volume and volume cancel, you are going to have number of mole of base conjugate divided by number of mole of acid. That's what we have. pH is equal to pKa plus log of number of mole of base divided by number of mole of acid. Here it's just that there are no brackets, but normal mole, there are supposed to be brackets here to show that it is logarithm of this fraction. So this one ne dépend du volume V. Donc si on dilute la solution tompo, le pH d'une solution tompo ne change pas. So because sometimes you might be asked in a question, why does the pH of a solution tompo, why is it that it doesn't vary even if you add some water, even if you dilute it? The answer is that this the pH of this solution, it does not depend on what? It does not depend on the volume. So la solution si on dilute la solution tompo, le pH d'une solution tompo le pH ne change pas. Pourquoi? C'est parce qu'il ne dépend pas du volume. That's the answer here. So is it clear or there are questions?
Yes, I have a question.
Yes, you may ask.
On the
I'm unable to get what you are saying.
I'm saying, could you please scroll up a bit?
Okay. Here?
Yeah. Yes. How did you
Yes.
come up? How did you come up with the pKa there?
pKa, okay. Let me take you back to what we did. I don't know if that PDF is here. Just a minute. Yeah. I had explained this, but just a minute. Let me just check if the PDF where I had put this. But you should let me check the PDFs where I had put these things if it is still there. Just a minute. Okay. Okay, I don't know the day, but we had done this. We had done something like this. We had an acid like this. Okay, like this was the general formula. That one we have specified, but using this general formula, you will get the understanding. So if you will follow it. So here we've got an acid is put in water. Like it would decompose, forming base conjugate A minus plus H2SO plus. So Ka is written by concentration of H2SO plus times concentration of the base conjugate divided by the concentration of the acid. And then we want to make H2SO plus subject to the formula, meaning we're going to cross multiply. We're going to have what? H2SO, concentration of H2SO plus times the concentration of base conjugate. That's what we have here. Is equals to Ka times the concentration of RH. That's what we have here. So we want to make H2SO plus subject to the formula, meaning we divide both sides by what? By a concentration of base conjugate. Concentration of base conjugate, meaning that we're going to have H2SO plus, concentration of H2SO plus is equals to this. Then we're going to introduce negative log both sides. Negative log, negative log. Meaning that negative log of H2SO plus is equals to negative log of Ka minus log of this fraction now that we have here. RH, an acid over what? Acid over base. So here we have what? We have a minus. And then pH is equals to, what is negative log of Ka? From the definition, if you revise the definition of negative log of Ka, I will say that it is P Ka. P Ka is given by negative log of Ka. And then here, when the denominator becomes the numerator, meaning a negative is generated, times the negative here, we have a positive here, meaning the denominator. If you interchange, the numerator becomes the denominator becomes the numerator. You will generate a negative times this one, we have a positive here. That's why we have pH is equals to P Ka plus log of base conjugate divided by acid. And that, if not mistaken, that's what we have here. pH is equals to P Ka plus log of base conjugate divided by an acid. Is it clear?
Yes, it's clear.
Okay. Then here now we have mélange d'un acide faible et base faible. pH d'une solution d'un sel d'acide faible et de base faible. So normalement, we know that when we mix an acid and a base, we form a salt. So let's see how we can find the pH of this salt. So acid faible, this one, this is the acid, plus base faible, this is the base faible. Together they will form what? They will form this salt. So let's say this totalement dans l'eau. So when we put this salt in water, it will decompose or it will dissociate, forming this base conjugate and this what and this NH4 plus. So we have this one now. Like this salt decomposes in order to form this and this. So we have this acid now, which undergoes decomposition in order to form CH3COO minus and H2SO plus. And then we have got NH4 plus. Just a minute. we've got we have this one, the NH4 plus, which comes from the decomposition of this salt. The NH4 plus, which comes from the decomposition of the salt. When it reacts with water, it forms NH3 and what? And the hydroxide. Forms NH3 and the hydroxide. NH4, like first this salt, when this and this reacts, they form the salt. When you put the salt in water, it decomposes to form this one and this one. So when this acid is put in water, it forms this one and this one. So from the salt, you've got NH4 plus. When it's put in water, it forms this and this. So neutrality electric. Neutrality electric, remember that we have to get those that have got positive powers. We add their concentration, it will be equal to the concentration of those that have got negative power. So from these equations, we have what? We have NH4 plus, concentration of NH4 plus times, or plus, not time, concentration of NH4 plus concentration of H2SO plus is equal to the concentration of those that have got what? That have got negative sign, which is base conjugate plus hydroxide. So on présence d'un acide faible et d'une base faible. So, donc, on ne peut négliger ni hydroxyde devant hydronium, ni inversement. Par contre, on peut négliger la différence. So here they are saying that we're in the presence of a weak acid and we're in the presence of a weak acid and a weak base. So we cannot neglect hydroxide in the presence of H2SO plus, and we cannot neglect H2SO plus in the presence of hydroxide. But we can neglect their difference, meaning if their concentration is what? Their concentration it is the same. Their concentration it is the same. So we cannot say that this one has to be neglected before this one, or this one has to be neglected before this one. But if you find their difference, you are going to find that it is equal to what? It is equal to 0. So from the formula, we've got this one, H2SO plus minus concentration of H2SO plus minus concentration of hydroxide is equals to 0. From the formula here, meaning if we take H2SO plus, it goes to the other side, meaning that here on the left hand side we're going to have what? We're going to have concentration of NH4 plus is equals to concentration of this base conjugate CH3COO minus plus hydroxide minus hydronium. We've been told that it is 0. So meaning that we are going to have concentration of NH4 plus is equal to concentration of CH3COO minus. That's what we have here. Concentration of CH base conjugate is equal to the concentration of this NH4 plus. So we have conservation de la matière. So concentration of the acid, conservation de la matière. So from the equation of decomposition of the acid, we have here. This is an equilibrium reaction which takes place in two directions. So in two directions. So because here, if we want to find the concentration of the acid, the initial concentration of the acid, we are going to say the concentration of the base conjugate formed plus the concentration of the acid that remained at equilibrium. It is equal to the concentration of the acid. That's what we have here. Concentration of the acid that remained plus concentration of the base conjugate that was formed from the decomposition of the acid. It is equal to the concentration of the acid, the initial concentration. The initial concentration of the acid, it is given by the concentration of the base conjugate formed from the decomposition of the acid plus the concentration of the acid that remained. Some acid remained because the reaction, because it was partial decomposition of this acid. And then concentration of the base. Concentration of the base. So we've got NH4 plus. NH4 plus decomposes in order to form this one and this one. So concentration of the base is going to be given by, so we say initial concentration of this, it is given by the concentration of NH3 formed plus the concentration of NH4 plus remained. That's what we have here. So in this case, of course, the concentration of the acid is equal to the concentration of the base. Concentration of the acid is equal to the concentration of what? Is equal to the concentration of the base. The concentration of the acid is equal to the concentration of the base. Why are we saying that? It's because, like, if you check, if this salt decomposes, it forms this one and this one. So the concentration of this one, it is equal to the concentration of this one. So the concentration of this one is equal to the concentration of this one. So the concentration of the acid is equal to the concentration of the base, which means that the concentration of this acid is equal to the concentration of this. Or maybe if you don't want to get it from that point of view, you can check here. We said that this one, base conjugate, is equal to this concentration of this acid conjugate. So here, concentration of the acid, where there is acid here, you can put what? You can put this. Where there is acid, where there is, here we've got concentration of the acid is equal to this one. So meaning that where there is acid, where there is this base conjugate, you can replace it with this. It's correct again, because this one, concentration of this is equal to the concentration of this. And where there is base, concentration of the base, we have this one. Meaning where there is this one, you can put what? You can put this again, because they are the same. So concentration of the acid is equal to concentration of the base. So il faut, on fait les produits. So here the decomposition, we can write the constant of this decomposition, the constant of this decomposition. I think I wrote this somewhere. Just a minute. Okay. From the decomposition of this acid, when this acid decomposes, forms this one and this one. So when we write Ka is equal to the concentration of H2SO plus times concentration of the base conjugate divided by the concentration of the acid. That is Ka1. And then Ka for this one. Ka meaning the concentration of the hydroxy times the concentration of NH3, it divided by the concentration of NH4 plus. We have this one. That's what we have here. So when we multiply these two, Ka1 times Ka, we are going to get this one. Ka1 times Ka, meaning we're going to get this one here. And we've been told that the concentration of the acid is equal to the concentration of the base, meaning that we cancel this one and this one, the concentration, they are the same. Concentration of this base conjugate is equal to the concentration of the acid conjugate, meaning we cancel this one and we cancel this one again. So when we cancel those, we are going to have what? And another thing is that concentration of H2SO plus is equal to the concentration of OH minus. So when we cancel this one and when we cancel this one and this one, we cancel this one and this one, we're going to remain with what? Ka1 times Ka is equal to concentration of H2SO plus times concentration of OH minus. and the concentration of H2O plus is equal to the concentration of OH minus, meaning where there is OH minus, we can replace with what? With H2O plus, meaning we are going to have Ka1, Ka is equals to H concentration of H2O plus squared. That's what we have here. Ka1, Ka is equal to concentration of H2O plus squared. So we introduce negative log both sides. When you simplify it, you have negative. You introduce negative log both sides, here and here. And then when you simplify it, you will have this. You have pH is equals to 1 over 2 pKa1 plus pKa. That's how it is. C'est le pH d'une solution d'un mélange d'acide faible et de base faible. Is it clear? Or there are questions somewhere? So, mélange d'acide plus base, réaction de neutralisation, dosage. So, just a minute. Okay. So, on a mélange d'acide plus base, reaction de neutralisation. So, this is also called the neutralization reaction or dosage. So, on mélange V1, acid 1, the concentration C1. So, if we mix this acid, number of moles will be given by, or number of moles of this acid will be given by the concentration 1 times the volume 1. V D, volume D, base D. The concentration here of sodium hydroxide. So number of moles of this given by concentration D times volume D. So trois cas peuvent se présenter. So we've got three cases that we can consider here. If we want to find the pH now of an acid, a mix of an acid and the what and the base. So if in the first case, if the concentration if the number of moles of acid is greater than the number of moles of the base, this is what is going to take place. So at first, we've got the number of moles of the acid, we've got the number of moles of the base. If you check the mole ratio here, it is what? It is 1 to 1, meaning that 1 mole of the acid will react with 1 mole of the base to form this salt. This salt, it is here, we didn't write it as in form of this one and this one together. It's because it is in water. So in water, they will exist as ions. So meaning that the one which is a limiting reactant here, it is the base because it is in smaller quantity, meaning the exact number of moles of this base will react with the number of moles, with the equal number of moles of what? Of the acid. The acid is in excess, the base, it is what? It is the limiting reactant here. So if we've got 2 moles of the base, meaning it will react with 2 moles of the acid. So to find the number of moles of the acid that remained, we will say number of moles of that acid minus 2. So here, at the initial state, before we don't have this and don't have that. So at final state, we are going to have what? The number of moles of the product that will be formed will be equal to the number of moles will be the same. The number of moles of the salt that will be formed, or these ions, it will be equal to the number of moles of the base that reacted, because all the base was finished, and the number of moles of what? Of the acid that remained is going to be found by saying number of moles of the acid, because it is in excess, minus number of moles of the base. The number of moles of this base that remained, it is 0 because it was a limiting reactant, and number of moles of the base conjugate formed because the number of moles of the base that was there initially. Number of moles of sodium plus sodium ion formed because the number of moles of the base that was there initially. Meaning that the solution now, the solution final, it will have what? It will have this the base conjugate, it will have sodium, and it will also have what? The acid. Some of the acid will remain. So the solution final contient this acid, the base conjugate, this one, a sodium. So sodium, it is indifferent. The solution est une solution tombe. So from this solution, we have found that we had the solution of this acid and the base. this is a strong base, so all the base was consumed, forming this one and this one. But some of the acid will remained, meaning at the end of the reaction, we're going to find the number of moles of the acid that remained. We're also going to find the number of moles of the base conjugate. We're also going to find the number of moles of the sodium. So now, first to find the pH, we need to check what are we remaining with. We're remaining with the acid, we're remaining with the base conjugate of this acid, and also remaining with sodium. So what is the nature of these substances that we are remaining with? So the nature of sodium, from the first part, if you check the we said it was indicated that sodium it is indifferent, meaning that this one it does not show characters of being an acid or being a base. So this one it is neutral, you put it in solution. But this one it will show characters of being a base. This one to show characters of being an acid. So when you mix an acid and this base conjugate, it forms what? Solution tombo. And the pH of a solution tombo is given by p Ka plus log of base conjugate divided by pH of a solution tombo is given by p Ka plus log of the base conjugate, concentration of the base conjugate divided by the concentration of the acid. You see, that's for the first case. For the second case, we've got number of moles of the acid is less than number of moles of the base. Meaning in this case, the acid is a limiting reactant, and the base it is the one which is in excess. So at first we won't have the ions formed because the reaction has not started. At last, since the acid here again, you have to check the mole ratio. Mole ratio is 1 to 1, 1 to 1. So the number of moles of this one, or the acid that was present, it will react with the base. So the same number of moles. If we have got number of moles of the acid 2, it will react with only 2 moles of the acid because the mole ratio is 1 to 1, meaning that we say number of moles of the, if we have number of moles of the acid as 2 moles, and then we've got number of moles of the base in excess, we're going to say that number of moles of the base that remained is given by the excess number of moles minus the number of moles of the acid. So that's why here the number of the acid was consumed, and here we've got number of moles of base that remained, which is given by the number of moles of the base which is in excess minus the initial number of moles of the acid. So here, the number of moles of the base conjugate and the number of moles of the sodium ions that was formed, the number of moles is given by the initial number of moles of the acid. So in short, if you have this situation, if you want to know what was the number of moles of the base conjugate formed, if the ratio is 1 to 1, just have to check, just have to get it direct. The initial number of moles of the acid will be the number of moles of the ions formed, because the acid was the one which was a limiting reactant. So in this case, at the end of the reaction, what are we going to have? We're going to have the acid won't have it 0. We're going to have the base. We are going to have the base conjugate, and we are going to have what? Sodium. So sodium Na+. So la solution finale contient la base faible conjugée. This is the base conjugée, but it is faible. Na+, it is indifferent. Et la base forte, sodium hydroxide. Donc la base forte impose the pH. So here now it is more like we have a mixture of base of the base faible, which is the base conjugate, and the what? It is base forte. And what? Na+. Na+, it is indifferent if you check from the notes. So we will just consider that we have a mix of base conjugate and this strong base. So base conjugate is a base faible. Sodium hydroxide, it is a strong base. So the one which is going to impose the pH, it is the base forte. So we've got pH of the base forte is given by so pH will be given by 14 plus log of concentration of the base. Concentration of the base is equals number of moles of the base that remain divided by the what? Divided by the volume total. So what was the number of moles of the base that remained? It is given by number of moles of the base in excess minus number of moles of the acid. So since we want to find the concentration, we say number of moles of the base that remained divided by the volume total. This is given by, this is what we call the concentration. So pH of the acid, pH of the base is given by 14 plus log of number of moles of the base minus number of moles of the acid divided by the volume total. So this one, NB minus NA volume total, this is the concentration of the base sodium hydroxide that remained. So at quasi-MK, we have equality. Here we've got number of moles of the acid is equal to number of moles of the base. So in this case, all the acid reacted with all the base that was present, forming this base conjugate and this sodium indifferent. So now the solution finally, it will have what? It will have sodium, which is indifferent, plus it will also have what? It will also have CH3COO, which is what? This is a base conjugate. So the one which is going to impose the pH, it is the base conjugate, and this one is a weak base. So what is the pH of a weak base? So here, before we rush here, we've got la solution finale contient la base faible conjugée, this one, Na plus indifferent. Donc la base faible impose le pH. So pH is given by, if you remember this one, we derived this formula for pH of a weak base. pH is given by 7 plus 1 over 2 pKa plus 1 over 2 log of what? Log of the concentration of this base. So what is the concentration of this base conjugate? Concentration of the base conjugate is equal to number of mole of the acid divided by volume total. Or instead of writing number of mole of acid, you can also write number of mole of the base divided by the volume total. Why can we write either? Because they are equal. Number of mole of the acid is equal to number of mole of the base. So this one now, cube de titrage acido basique, dosage de acid 4. So this one now, you are going to do this in practical. So we are not going to cover this chapter. You are going to do titration. So this one you are going to do it in practical. Le dosage revient à déterminer la quantité d'acide ou basique present on solution. So this one you're going to do in what you're going to do. This is titration. We're going to do everything here, and then I'll leave this part for the practical. So we have ended our journey has ended here. But I had prepared some questions. If you remember, I promised that there is one question that I'm going to solve and send you the answers, and it's there in the PDF that I sent. If you remember last time when I was giving you when I gave you that exercise last time for gas perfect. So if you have some problems, maybe you should try to watch the video several times, try to read the coup. And if you don't understand it, you can inform me so that I explain to you. But I'm sure that you have the general understanding now. There are just a few things that have to be cemented. Now, those things that have to be cemented, they will be cemented through the questions that we will be doing. So, just a minute, give me 1 minute. Okay, on continue. So we've got this question. The question is saying, dans un récipient de 5 litres, on introduit 0,1 mol d'hydrogène-sulfure d'ammonium. So this is ammonium hydrogen sulfate. This one, il s'agit alors, il s'établit alors à 25 degrees Celsius, l'équilibre se forme. So here we've got a container which measures the volume of 5 liters. So in this container, they've put 0.1 mole of this compound, which is called hydrogen sulfide ammonium, and this is the these are the products formed. So they're saying that when the temperature reaches 25 degrees Celsius, this is the equilibrium that is formed. So définir et calculer la variance so you know the definition of the variance already. This is the definition. So the variance is given by C plus P minus this number of phases. So we have C is given by K minus N minus R, where K number de constituent, K is equals to 3. Number de constituent, we have 1, 2, 3. K is equal to 3. N number d'equilibre. Number d'equilibre. So K, if you remember, say that for N you need to check on the side of the products. If you have gas, check, okay, the number of moles of this gas are equal to the number of moles of this gas, meaning I have a relationship between these two. There is a relation, and that and N is equals to 1. So, and the other thing is that sometimes you might have number of moles of this might be twice, or maybe it might be half the number of moles. You've got gas, or maybe, yeah, if you've got gas, just know that you've got a relation between these two. So that's why N is equals to 1. R, number de relation. No, R at what? Just a minute. R, number de relation is equals to 1. Here there is a mistake. N, it is the one, N, which is the number of relation 1. R, it is the number of reactions. And R, it is the number of reaction. R, it is the number of reaction. N, it is the one number of reaction. So this one is what I've explained. That's what R means. Then let me restart. I've swapped these things. Sorry. K, I said that K is equal to 3. N, it is the number of the relations. This explanation here for the explanation which is here for. Okay, in short, let me just do it this way. Where there is R, there's supposed to be N. Where there is N, there's supposed to be R. Let me correct it so that. So here is R. R, it is the one number d'equilibre. We've got one reaction here. This is R. And then, yeah, this is R. I'm sure you've seen the corrections here, the correction here. And then this is N. This is what? This is petit n. So N, this is R, this is R, nombre d'equilibre. This is, yeah, R, nombre d'equilibre, R again here. So this is what? This is R, nombre d'equilibre or nombre de reaction. This, we only have one equilibrium here, and then, yeah, so that's why we have one. So here is what? N, nombre de relation, N is equals to 1. Okay, yeah. So here we have got n nombre de relation. N is equals to 1. K à l'équilibre with the pressure of NH3 is equal to the pressure of HDS, as I explained already. You can see the pressure of this is equal to the pressure of this. So the number of moles of this is equal to the number of moles of this. It's one and the same. So P is equals to what? P is equals to D. So P, before you conclude that P is equals to 2, you need to check, okay, what is the value of the delta null? Here we've got 2. 2 minus, here we don't have gases, 0. So the value of delta null, it is what? It is not equal to 0, meaning that the pressure, it plays a what? It plays a role, and the temperature also plays a role, because they've not said that it is a reaction anthemic. So both temperature and the pressure, they play a role. So number the phase here, we've got how many phases? Here we've got solid and solid, they form one phase, and gas, gas and the gas together they form one phase. And solid, we've got one solid, a solid in its own, it forms a phase. So we've got two phases, phase gas and phase solid. That's why here we've got number of phases equals to 2. So if you replace this, you are going to find that your variance is equals to 1. So the question is saying, the other question, exprime la constante d'équilibre Kp en fonction de pression partielle. So the at initially we have the number of moles, this one 0.1. They've said in the question that we've got 0.1 moles. Here we have the number of moles of this 0, 0. So at T final or at equilibrium, we're going to have 0.1 open bracket 1 minus alpha. Here we're going to have 0.1 alpha, 0.1 alpha. So here, that's where most of you, not most of you, but most of the students make a mistake. Even me, the first days I was studying, I was doing this. I used to make a lot of mistakes. Like when finding number of mole total, you find that usually we forget not to include the solid. Even me personally, like before I got used with these questions, I used like to include the number of moles of solid. Meaning that I was finding my answer to be wrong, and if this answer is wrong, mean everything that will fall, it will be wrong. So you have to pay extra attention that you don't include liquids, you don't include solids. The only things that should be included when finding n total should be gases. Please take note of this. So in total, we've got number of mole 0.1 of the gas alpha times 0.1, or as in now 0.1 plus 0.1 here. That's why we have 2 times 0.1 alpha. We add this one and this one. We don't add the forward for solid because we're dealing with pressure, and this one doesn't exist any pressure in this container. It is only the gases which are characterized by the pressure. So Kp is going to be given by the pressure of this one times the pressure of this one. But here we don't have what? We don't have gases here. So we will only consider the gases here. So Kp will be given by the pressure of this one, the pressure of NH3 times the pressure of HDS. That's what we have here. So Kp is equals to, what is the pressure? The pressure of this is the number of moles divided by the total number of moles. The pressure of this is equals to the number of moles here divided by the total number of moles. So times, like the partial pressure, the number of moles, this one 0.1 alpha, divided by the total number of moles times pressure total, number of moles of this divided by the total number of moles times pressure total. So since we're multiplying pressure total, which means we're going to have pressure total squared. And the number of moles of this, they are the same as the number of moles of this. Meaning, if we can just say the 0.1 alpha divided by 0.2 alpha, everything squared. That's what we have here. So from this, alpha and alpha is going to it will cancel. We're going to have 0.1 over 0.1 over 0.2, which is 1 over 2. So 1 over 2 squared, it is 1 over 4 squared, which is 1 over 4 times the pressure total squared. 1 over 2, or half squared, it is 1 over 4. We've got pressure total squared. That's why we have written pressure total squared. Here on l'expression de la constante d'équilibre quasi donne sa value. So you need to know how to derive this one again. You need to know how to derive this one. Like we did this in the coup. So Kp is given by Kc times RT to the power delta node. This is not delta gamma, it's delta node. So here, if we want to find the Kc, we have to divide by RT delta to the power delta node, RT to the power delta node. So that's why it's written Kc is equals to Kp times RT to the power negative delta node, which means that this one it is a denominator. So where there is Kp, we've been given in the question that Kp is 0.06, open bracket. Where there is R, you replace this the value for R, and you have to replace where there is T, you replace here it is the value for what? It is the value for this is the temperature, 25 degrees Celsius. So 25 plus 273, you've got 298. Divided by delta null, you have got what? You have what? You have 2. We've got 1 plus 1, it is 2. 2 minus 0, it is 2. So here, since it's negative delta null, that's why it's written negative 2. When you simplify this one, you will get 10 to the power negative 4. For you, there are several values of R. What is going to give you the direction on which value of R to choose? You need to check carefully in the question. You need to look very, very, very well. If you check your question again, you will find that Kp has been given in what? In atmosphere. So, meaning that your R has to be the constant, the one that you use in atmosphere. If you use another R here, everything will be wrong. So, the other question, déterminer la pression totale à l'équilibre, déduire les pressions partielles de chaque gaz. So we have this relation. Kp is given by pression total squared over 4. Meaning we can just cross multiply like here. We can just cross multiply. We have the value for Kp. So we just want to find the pression total. So when you cross multiply here, you are going to find that a pression total will be given by the square root of, like you have Kp is equal to pression total over 4. When you cross multiply, you are going to have pression total squared is equal to 4 times Kp. Meaning if you introduce square root on both sides, you're going to have pression total is equal to square root of 4 times Kp, which is what? Kp, so it will be 4 times, square root of 4 times 0.06. We're going to have 0.49. So this is the value for the pression total. And then now, if you want to find the number of moles, if you want to find the partial pressure, of each of these. So the partial pressure of NH3 is equal to the partial pressure of HDS, which is given by, so if you remember the partial pressure of this, it is given by the number of moles 0.1 alpha divided by the number of moles 0.2 alpha times pression total. So this is the same as 1 over 2 times pression total. So 1 over 2 times pression total, that's what we have, pression total over 2. So 0.49 divided by 2, you have 0.245 atmosphere. So this is the pressure of this, and it is the pressure of this. You have to be careful here, like from the exercises that I give. Some of you were like, maybe you were not paying much attention to what to, maybe like what you were writing. You find that here instead of writing 0.24, you write 0.42. It is wrong. So you have labored to come up with all these answers only to get the final answer wrong. So you need to be verifying. At least you punch even 2 times on the calculator. Is this answer correct? Okay. Is this answer correct? Okay. You must be sure with the answer that you write, because every mark counts. So calculate the degree de decomposition alpha. So how can we calculate the degree of decomposition of alpha? Here we have been given the present total, we have found it. So we can just use the equation of gas perfect. So equation of gas perfect is saying that present total times volume is equal to number of mole total times R times T. So we make present total subject to the formula, mean we're going to have number of mole total times R times O volume. Again, pay extra attention. Number of mole, it is only the number of mole of the gases which we consider here. So it's the number of mole of the gas. Number of mole of the gas. it is what? Number of mole of the gas, it is 0. It is 2 times 0.1 alpha, which is 0.2 alpha. So here you have what? So you have present total is equal to 0.2 alpha times RT divided by what? Divided by the volume. So you can cross multiply. You have present total times volume is given by 0.2 alpha RT, meaning you are going to divide by 0.2 RT, 0.2 RT, and you are going to have alpha is equal to present total times volume divided by 0.2 RT. So where there is present total, you need to replace with this one 0.49. Replace with 0.49. Where there is volume in the question, you've been told that it is 5 liter, if not mistaken. Yeah, volume you replace with what? With 5 liters. So volume, it is 5 liter. Yeah, volume, it is 5 liter. R it is 0.082. The temperature in Kelvin. After simplifying this, you are going to get 0.5. And then the question number 6. On verra ramener cette décomposition à 1%. Quel est le nombre de moles de NH3 qu'il faut ajouter dans le récipient avant l'établissement de l'équilibre? So here alpha, our alpha has been found to be what? To be 0.5. 0.5. It is our alpha. So 0.5. This is what? This is 50%. The decomposition was, it is 50%. Now in this case they've said that we want to have a decomposition of 1%. In our reaction we want to have a decomposition of 1%. So the value of alpha must be 1%. So what is the number of moles of NH3 that we are going to add in order to have the decomposition which is 1%? What is the number of moles we are going to add in order to have the decomposition which is 1%? So the number of moles that have to be added before this reaction reaches the equilibrium, meaning that before the reaction starts, we must have a certain number. Before NH3 is produced, we must have the number of moles of NH3 already, so that with that number of NH3, because of that number of moles of NH3, the decomposition will just be 1%, meaning the alpha that will decompose will just be 0.1. I mean, the number of moles of NH4 that would decompose will just be 1%, which is 0.01. So this is the value of alpha, 0.01. So at T initial we have number of moles is 0.1, and the number of moles of this one we just have A. These are the number of moles that they have asked us in question. We just have A. And here we have the number of moles is 0. Number of moles total we have for gas, we have just A. The number of moles that we want to find A, that we have added initially in order to have the decomposition, in order to have what? To have this decomposition at 1%. So the number of mole, at T final, number of mole of this solid we have 0.11 minus alpha, 0.1 open bracket 1 minus alpha. And the number of moles for this one will be the number of moles that were there initially plus the number of moles that were formed, which is 0.1 alpha. Here we have 0.1 alpha. And the number of moles total, if we add this one and this one, we're going to have alpha plus 0.2. I mean, we're going to have, here it is A, not alpha. Take note, this one and this one, they are different. This is A and this is alpha. So number of mole of NH3, we're going to have A plus 0.1 alpha. Number of mole of this formed, we're going to have 0.1 alpha. Number of mole total of the gas, we're going to have A plus 0.d alpha. So à température constante et à volume constant, si on change le nombre de moles total, on change la pression. Par contre, Kp reste constant. Puisque this is just a typing error. This is puisque, not, let me just correct it. So here they're saying that since the number of moles now have changed, if the number of moles have changed, meaning, so when the temperature is constant, the volume, and the volume is constant. So if we change the number of moles, meaning that the pressure, again, it will what? The pressure, it will change also. The number of moles have changed because we have added A, we have added the number of moles called A. So the pressure has changed. The number of moles has done what? The number of moles has changed also. What has made the pressure to change? It is because the number of moles have changed. But the volume, it is constant, and the temperature, it is constant. So if the temperature is constant, meaning that the constant Kp, it will not change. If you remember earlier on, I mentioned that Kp only changes when the temperature changes. If the temperature is constant, Kp will not change. So in this case, Kp is given by the pressure of NH3 times the pressure of HDSS, which is equal to the pressure of NH3. Partial pressure of NH3 is given by the number of moles, this one R plus 0.1 alpha, divided by R plus 0.d alpha, times the pressure of HDSS is 0.1 alpha, divided by R plus 0.d alpha, times pressure and total squared, because we are multiplying by pressure and total, That's why I've got pressure and total squared. So pressure and total, it is given by number of mole total times R times T divided by the volume. So what is the so meaning that where there is pressure and total, you can just replace with this one, N total times R times T over volume. This comes from the equation of gas perfects. So meaning that where there is N total, you can replace with what? With R plus 0.d alpha times RT over volume. This is the number of mole total of the gas, R plus 0.d alpha. So where there is Kp, we go in the equation for Kp. So yeah, this one. So here we have Kp is given by, this is what we have here. I have just replaced where there is what? Where there is pressure and total. So where there is pressure and total squared, I have replaced with this squared. So here I'm multiplying with this squared. If you multiply with this squared, meaning that you're going to have, you square this one, you square this one, and the volume is squared also. So if I am multiplying with the R plus, with this squared, like I've put this R plus 0.d alpha times RT divided by volume, where there is pressure and total squared. So meaning that this one, it will be squared, R plus 0.d squared, it will be squared here. R will be squared, T will be squared, the volume will be squared. So here I've got R plus 0.d alpha squared. It will cancel with this one from pressure and total squared with this one. After simplifying, I'm going to have this one, R plus 0.1 alpha times this. So I want to make alpha subject of the formula. First of all, I will cross multiply. After cross multiplying, I make alpha subject of the formula and substitute where there is value for Kp 0.06, volume 5 liter, 0.1 times alpha. The value is what? 1%, which is 0.01. R 0.082. Temperature 298. Yeah, 25 plus 273, if not mistaken, 298 if you punch on the calculator. 25 plus 273 minus 0.1 alpha. Alpha, it is what? 0.01. So 0.1 times 0.01. When you simplify everything, you will find that your value for R, it is 2.5 mole. So meaning that if you add 2.5 mole of the, if you add the number of moles of NH3 equal to 2.5, if you add the number of moles of NH3 equal to 2.5 initially in that container, meaning when this one decomposes, the decomposition, it will be at 1%, meaning that the value for alpha will be at 1%. This is what it means. Are there any questions?
I was kindly asking if you could repeat again here.
Okay, where didn't you get it exactly? Like, I'm trying to move fast because we are remaining with 20 minutes and we have not touched any question on acids and bases. So you can just tell me exactly where you are not clear so that I explain, then we move.
On the squares, see all the squares are cancelling each other.
Okay, do you have a pen there where you are writing, like there, so that maybe if you can have a pen, like if you can be writing what I am explaining, since I didn't write it somewhere, like here. You are sure how we came up with this present total squared here? Hello?
Huh?
Are you sure with how we came up with this present totally squared here? How we arrived here? Are you sure? Or do you know how we arrived here?
I'm a bit sure.
A bit sure. Okay. Copy, Copy is given by what? Present of this one, NH3, times present of this one. Since in this reaction we only have two gases, and copy it is only dealing with gases. So copy is only dealing with what? Copy it is only dealing with gases. So this means that we are going to say the partial pressure of this gas times the partial pressure of this gas is equal to Kp. So what is the partial pressure of this gas, NH3? The partial pressure of the gas NH3 is given by the number of moles that are there at equilibrium for NH3, which is the number of mole initial plus the number of mole formed, R plus 0.1 alpha, divided by R plus 0.2 alpha, times present total. That is the partial pressure for NH3. And then the partial pressure for HDS, it is given by the number of moles for HDS, the number of moles of HDS, which is 0.1, divided by the total number of moles alpha, R plus 0.1 alpha, R plus 0.1 alpha, times present total. So, meaning that on top you are going to have what? R plus 0.1 alpha times 0.1 alpha times present total squared, because we're multiplying with present total, we're multiplying with present total. That's why I've got present total squared. On the denominator, we have total number of moles, and here we've got total number of moles. Since we're multiplying, we have total number of moles times total number of moles. And what is the total number of moles? It is R plus 0.2 alpha. So we have total number of moles squared, because we're multiplying total number of moles times total number of moles. That's how we arrived here. And then we said, okay, this one now, the present total, it is given by the equation. We can find it using the equation of gas perfect. The equation of gas perfect is saying that PV is equal to nRT. So present total is equal to N total times R times T through volume. So present total is given by number of mole total times R times T through volume. Meaning that where there is present total, I can replace with this one. But check here, you've got present total squared. So meaning that when you're replacing this one, you need to replace it as a square here. You need to square it also. And then number of mole total. Number of mole total, I have replaced our R plus 0.2 alpha. Meaning that here I have done what? I have replaced where there is a number of mole total with this one. So before replacing here, when I replace, I will square this one. So meaning that from this now, where there is present total, I will have open bracket R plus 0.2 alpha close bracket squared times R squared times T squared divided by volume squared. So since here I have got R plus 0.2 alpha in bracket squared, and down I have R plus 0.2 alpha in bracket squared, it will cancel. So this will cancel with this when it is squared here. And I'm only going to remain with this one. And from this one, I'll just do the simple mathematics, which is the cross multiplication, and I group like terms together. I will have this one here. This one, I have all the values from the question. I have the value for Kp, I have the value for volume, I have the value for alpha, which is 1%, 1 over 100 is 0.01. R I have, which is 0.082. T I have, which is 25 plus 273. Minus 0.1 times alpha is 0.01. When I do the correct mathematics here, just punching on the calculator, you will have 2.5. Here, you might not see it because I did not write it here. Like sometimes I try to I try to reduce, like I didn't want to write each and every step, like, but with the time you will be studying, if you will be studying as you're watching this video, since it will be uploaded, you should try to follow each and every step. Where I said, okay, here I squared, here I did what. You will see that from what you'll be writing, you will get it. Here, it is only one step which is skipped, where this one was squared and replaced here, showing how this one cancelled with this one here. Is it clear?
Yes. It's clear.
Okay. Okay. Yeah. So,
Same one.
hello.
Yeah, on the same part where
Yes.
we squared. Yeah. Is
Yes.
S? Did you square A there?
A, which A? This one.
This. Yes.
Look. Here it is like number of mole total is given by R plus 0.1 alpha. Like this, I'm taking it as one thing. So when it is squared here, like, okay, just imagine we have when we replace this one, here, we have to square it. That's when it will fit here, because we had the present total is squared, and present total is given by this one. So when we square this one, it means we have squared this one. Like here we've got present total, meaning present total, we have to square this one. So here I have to, since this one R plus 0.2 alpha, it is one thing, I just have to put square outside the brackets here. It will appear just like R plus 0.2 alpha squared. So this one, it will cancel with the one I am multiplying with, that I will substitute. Here I will have 0. Here down I have R plus 0.2 alpha squared, and on top I will have R plus 0.2 alpha squared. So that one, it will cancel with this one, meaning the whole of this thing that I have here, this, it will cancel with the one that I will have on top after doing the replacement of present total squared. That's why I said that you will see it clearly how it cancels if you have followed my explanation. Like the time you will be studying, since I didn't prepare this, like, to write it as usual, like the way I write in these PDFs. So like what you have to do when you will be doing your calculation, since if I start writing this, we might take long, and we will touch maybe just one question on acids and bases, and that's where there is need of a lot of things. Here it is just the chemistry is done. Here it is just the mathematics now. We have found that present total is equal to this, is given by this, and we've replaced the number of mole total, we've replaced to be R plus 0.2 alpha. So here we've got present total, and present total we've been given that is this, but it is squared. We need to square this one. So here, just multiply with the whole of this thing. You square it, you will see that everything cancels. If you do the correct mathematics, you will arrive here. Is it clear?
Oh yeah, it is clear now.
Here it is just the mathematics here, like it is just the replacement. Just get this one, you put it here, you square it, and then you do the correct mathematics. Make A subject of the formula. You will see that this A, it will this R plus 0.2 alpha in bracket squared, it will cancel with the one that will be on top. This one, how is it going to be squared? Because I have to replace it with its present totally squared. So everything, this, and this, they will all be squared. We can move.
So
Should I move, or maybe I should explain further?
we can move, you know.
Ok. So, indiquez en justifiant la réponse dans quel sens évoluera l'équilibre de décomposition de this compound. Si l'on procède à une augmentation de la pression totale, so in which direction is this equilibrium going to move if we increase the total pressure? So, if we increase the total pressure, you need to check what happens. You have to master those we did in the pool, like how pressure, temperature, how they influence the equilibrium. So you need to check, where do I have a large number of moles? It is this side. So meaning, if you increase the pressure, the system will respond by reducing the pressure. How is it going to reduce the pressure? By shifting the equilibrium towards the reaction, towards the side where there fewer number of moles. Here I have 0 number of moles, so the equilibrium will shift towards the side towards the side where I don't have a lot of number of moles. It will shift in zones there in order to reduce the number of moles. So see on ajoute this one solid. So if you add this one solid, if you add unconstituent, meaning the equilibrium will shift in it will shift in another direction in order to consume what has been added. So meaning it will shift like in normal. If we add a constituent, if we add a reactant or a reactive, the equilibrium is going to respond by shifting in the direction that favors the consumption of that substance that has been added. But before we go to that, we need to check what are we dealing with. Here we're dealing with gases. We have what? We have got Kp. So if we add the NH4+, does this solid participate in finding the value for Kp? No, this solid does not participate. So whether we add this one, it will not influence the equilibrium. The equilibrium can only be influenced if Kp has been influenced. So this one does not influence Kp because it is a solid. So si on ajoute solide, pas d'effet sur l'équilibrium. So rien ne va changer ici. Si on ajoute un gas inert. So before you come to the conclusion of the gas inert, you need to check first, okay, if I add the gas inert, before you come to the conclusion, you need to check, okay, is the value for delta null 0 or not equal to 0? Also, the value for delta null, it is not equal to 0, meaning that if I add the gas inert, the equilibrium will shift towards the side where there is a lot of number of mole of the gas, which is the sense one. It will shift in the one direction that will be favored to the forward direction in order to increase the number of mole of the gas. So correction de l'acide de pH. Now this is when we started dealing with pH. So calculez la molarité des solutions suivantes. If you remember, we did, you know, the definition of molarity from what we did in the course. So we've been given a solution. Sodium hydroxide 0.5 N. You have been given 3N. You have been given this number N. So from the definition of molarité, normalité, I mean. So normalité, c'est la normalité est le nombre d'équivalents grammes d'un solide présent dans un litre de solution. Une solution normale ou une fois normale contient un équivalent gramme per litre. So P is equal to nombre de protons échangés au cours de réactions acido-basiques ou d'électrons dans le cas des réactions d'oxydo-reduction. So normalité, we did, like, we just did the definition, but we didn't do examples. So normally they said that if it is a solution, a base, it is the number of hydroxide that are found in 1 liter of a solution. If it is an acid, the number of protons H plus that are found in 1 liter of that solution. If it is a solution of oxidoreduction, it means that oxidoreductive means that it's the number of electrons that are found in that solution. So we've got molarity. Molarity, you know already the definition of molarity. So we have also concentration mole. This is the concentration which is in a gram per watt, which is in a gram per liter. So concentration mole, la masse d'acide or the base dans litre de solution. So here they're saying that concentration massique, concentration massique, it is the number of mass of an acid substance or a basic substance that can be dissolved in 1 liter of a solution. So normalité, here you must know the concentration. Normalité is a concentration mole sont réduites par la réaction suivante. So normalité is given by P times C. So P, if it is a solution acidic, it is the number of what? Of hydrogen given out. If it is the solution basic, the number of hydroxide given out. If it is the number, if it is if it is a solution oxidoreductrous doing the number of electrons. So this is the relation between concentration in mole and what, and concentration mass. Concentration mass is given by the concentration times the what, times the mass mole. This is the mass mole m. This is the relation between concentration in mole per liter and concentration in what, and concentration in and concentration mass. So calculate, now we go to our question. Calculate la molarité des solutions suivantes. Calculez la molarité des solutions suivantes. Calculez la molarité des solutions suivantes. So here we've got the solution sodium hydroxide. We've been given that we want to find the molarity of this solution of sodium hydroxide, which is 0.5 and 0.5 normal. So calculate la molarity. Oh, not this is another question. So here they want us to calculate the molarity. So sodium hydroxide decomposes to form what? When it is put in water, it forms the sodium plus hydroxide. So hydroxide the sodium etun monobase. So monobase, it means that it gives out only one hydroxide ion. This one, when it decomposes, it gives out only one hydroxide ion, meaning that P is equals to what? P is equals to 1. So if we go in our formula, we said, if we go to our formula, we said N is equal to P times what? Times C. So we want to find C, meaning C will be given by N divided by P. So P, the number of hydroxide, or the number of electrons, or the number of what? Of hydrogen ions given out. So here, the concentration is given by N over P. So N divided by P. What is N? N here, it is 0.5. Divided by P, it is what? It is 1. Meaning that we have 0.5 divided by 1, which is just 0.5. 0.5 more, or 0.5 more per liter. So we've got sulfuric acid. So sulfuric acid we've been given by normality 3N. So sulfuric acid decomposes to form, when it decomposes with, when it reacts with 2 moles of water to form hydronium 2 H2SO plus 2 moles of hydronium plus plus this radical here, this anion. So lastly, the sulfuric diacid. Diacid meaning that it gives out 2 protons, H2SO plus. Normally, therefore, la molarity. So here we have our P will be what? Our P will be equal to 2. You just have to look here. How many acids does it give out? It gives out 2. How many, hydrogen does it give out? It gives out 2 of the hydrogen ions. So meaning that P will be equal to 2. So our concentration is given by N over 2, which is N, it is 3 over 2. So 3 over 2 is what? It is 1.5. So 1.5 more per liter. So this one, it gives out 3. It is the same procedure. This one, just have to look at the nature of the acid. This one gave out 2. We have this phosphoric acid, it will give 3. So here, these are simple calculations. You just have to know the formula, just have to know what has been given out. And here, it is the opposite of what we were doing. It is the opposite of what we were doing. So I won't explain much here because they are direct things. Like here, this acid, it gives out 1. So you need to know the nature of the acid. Okay, this acid, how many hydrogen ions does it give? This one will give 1. This one will give 3. You see, this one is what? This is sodium hydroxide. So this is a solution. How many is it going to give out? This, it will give out 2 of hydroxide. I just want to make like this one. So for this one now, we were given what? We're given in form of concentration mass. So this one, you need to first find it concentration mole. That's when you can use that formula. So you need to find concentration mole. So in this question, we are finding what? We are finding the normality. We were finding the normality. So here, there's just a mistake. It is just a typing error. This is not C over 2. It is C times C2. So this is not 0. So like here, I'm moving a bit fast. I'm sure you will be able to find this because you just have to use the formula. It is the same things that I was doing like this. Here I was finding the concentration. I was given the normality. Now I will be finding the normality. I've been given the concentration. So here I've been given the molarity for this one. I can find the normality just using the formula. N is equal to P times C. So this one gives out 1, this one it gives out 3, this one gives out 2, this one it gives out 2. So here concentration is given by concentration is given by concentration mass heat divided by the mass mole. So what is the mass mole of sulfuric? It is what? 2 times hydrogen, which is the mass of hydrogen, it is 1. So 2 times 1 plus 32 for sulfur plus 4 times 16 for oxygen. You will find that the total mass mole of this one, it is what? It is 98. So if you divide this by 98, you are going to have 0.24. You're going to have 0.24 mole per liter. So this is the concentration. But we've been told to find what? We've been told to find the normality N. We've been told to find the normality N. So N is given by P times C. So what is our P? When this decomposes, it forms 2 hydrogen. It gives out 2 hydrogen ions. So it will be 2 times the concentration. Since N is equal to P times C, it will be 2 times C. So here there is just a mistake. Let me correct it. Is 2 times 0.24, and this one it will give us 0.048. So this one it will give us 0.48 molar. We are multiplying, not dividing here. Take note of this correction as you'll be studying. Are there questions on normality and molarity? Any question on normality and molarity?
No.
It's clear? I'm unable to get your response. Is it clear here?
Yes, it's clear.
Okay. And then now we have this one. Calculate le pH de solution aqueous suivante. Calculate le pH de solution aqueous suivante. So we've got this solution, hydrochloric acid. So the concentration we've been given to, as I said earlier on, like most of these Moroccan professors, they just write like 210 to the power negative 2. This means 2 times 10 to the power negative 2. Take note of this. It is in standard form. Some of them, they don't usually write the point. So you have to be careful. Don't punch 210 to the power negative 2. It will be wrong. It's 2 times 10 to the power negative 2. So this is a strong acid. So it would decompose in order, forming this one plus this one, meaning all of it is what we would decompose. So it is such an acid for dissociation total. So pH is given by negative log of H2O plus. So cette relation indépendante de la nature du monoacide for a variable. So we have the conditions. So if it is a strong acid, meaning that its pH has to be less than or equal to 6.5. If you remember, we came up with the scale that if an acid is real, its pH has to be less than or equal to 6.5. If you remember, you try to visit the book. We came up with these conditions. We were the ones formulating these conditions. So see pH less than or equal to 6.5. So easy, meaning the concentration has to be greater than 10 times negative 6.5. So if we have concentration greater than 10 to the power negative 6.5, meaning that l'autoprotolyse de l'eau est négligeable devant celle provenant de l'ionisation de l'acide. So if the autoprotolyse, it is negligible. So let's check if this condition, it is what? If this condition, it is verified. So 2 times 10 to the power negative 2, for you it is greater than 10 to the power negative 6.5. If you punch these values on the calculator, you will see. And then it means that the pH, it is that of a strong acid. It is given by negative log of concentration of H2SO plus, which is equal to negative log of concentration initial. What is the concentration? Concentration, it is 2 times 10 to the power negative 2, which is 0.02. And if you punch negative log of 0.02 to give you 1.7. So this is the pH. Is it clear for this question? Can someone respond if it's clear or not?
As in, for me, honestly, it's not clear. My laptop had some problems, so I didn't get anything. I'm just from like fixing the problem right now.
Okay, I was saying that this one, it is a strong acid. This one, when it's put in order, it is a strong acid. And the pH of a strong acid, it is given by pH is equal to negative log of H2SO plus. So you can't just start replacing here. You need to verify if autoprotolyse of water was included or it was not included. So you have this condition. If the pH is less than or equal to 6.5, it means that the concentration has to be greater than 10 to the power negative 6.5. So in short, you just have to verify this condition. If your concentration is greater than 10 to the power negative 6.5, it means that autoprotolyse of water won't be included. And I'm sure you know now what autoprotolyse de l'eau is, because we did this in the book. So if the autoprotolyse of water is not included, meaning that, so before you conclude here, you need to verify, put your concentration that you've been given here, and you've got what 2 times 10 to the power negative 2 mole. It is, and for you it is greater than 10 to the power negative 6.5. That's when you can conclude here that l'autoprotolyse de l'eau est négligeable. So if autoprotolyse est négligeable, meaning that your pH will be given by negative log of H2SO plus. And what is the concentration of H2SO plus? All the acid decomposes to form H2SO plus and chloride, meaning the concentration of initial of the acid is equal to the initial concentration of H2SO plus formed. So just put your, what is your concentration? 0.02. So your pH is given by negative log of 0.02. And if you punch negative log of 0.02, you will get that your answer is 1.7. Is it clear?
Oh, so that 2 times 10 to the power negative 2, it was given in the question?
Yeah, it was given as concentration here.
Oh, okay. It's clear then.
Yeah, so now I want to proceed like here. As I said, I was supposed to stop at 20:08. Like I have to go and pray. I have to go at the mosque. It's time for prayer now. So I don't know if this should be our last meeting, or maybe you still want, because there are a lot of questions that need some explanation. So for me, I had thought as if maybe we were going to cover maybe 4 or 5 questions on pH, but unfortunately, we've only covered 1. So it would depend on you, but like this PDF that I've sent for you, each and every question, it is explained. There is an explanation. I solved it. The question you solved, there is an explanation down. Why you put this, why you put that, they are steps. So it will be up to you. If you think like you can understand them by going through them, it is well and good, because all the questions are answered. But if you still think that maybe you'd like to do a few questions with me, maybe we can organize a day. Maybe we can do maybe for 1 hour, 1 hour 30 minutes. Since now I won't have enough time as I'm preparing for exams. I'm studying exams in a week from now. So I want to hear your views. Like, should this be our last coup, or maybe you want us to do some questions? or maybe you are going to do them on your own since all the answers are provided here?
As in for me, I think another one would be okay. Another cool. As in for me, I don't know about the others.
Let them say their views also. So Rosemary and Jabez, I don't know if the one who was responding was Kenneth or Jabez. So what are you saying?
As for me, I
Yeah,
can
it
say
would be okay to have.
I didn't get anything. Okay, Jabez start, then Rosemary will finish.
okay. I was saying that yes, for me, I think this one should be the last one, and
Okay.
we'll try to go through the answers. And why were not clear, you are there. We'll ask you.
Okay. Then Rosemary.
I think since we'll be free, it would be okay to have another class. Just one more.
Just one more. Okay, so Samantha is not there. Samantha is gone. I wanted to hear the views of each one of you. So some are saying that this should be the last one. Others are saying that we can organize another one. So okay, we'll make it like this. Like Kenneth, what did you say at first? You said it should be the last one, or we organize?
No, I said to organize another one.
Okay, so we are going to which day? Wait first, which day?
Whenever you're free.
Okay, so we will make it like this. For now, let me see like how my timetable will be, since I'm a bit under pressure. Like I have to be ready before the exams start. So before the exams start, so I will inform you in the group next week if I will be free. Like where I will be free, I will inform you the time. I will inform you in advance so that you tell me if you will be free also at that time or not. So once I check how my program will be for next week, then I'm going to inform Daisy so that he can arrange a class for us. Because yeah, some questions you can understand them, but they will need some just some small explanations. But even before for us to do a lot of questions, I ask that you should try to go through these questions, try to get some understanding here and there, so that when we meet next time, we should just move fast. Because if you won't understand most of the things, meaning that we're going to be moving at a very slow rate, and we are not going to cover a lot of things, you see. So you should try to revise these questions, try to revise the where you're not understanding it, try to revise it. But for this one, I'm sure like most of the things are clear. So next week we are going to meet, inshallah. So we'll stop here. Good night, everyone.
Good night.
Okay, thanks.